Greetings everybody, and thank you for joining us on our sixth free webinar here at Blazedpath. I'm joined today by Gustavo Merchan. He's our managing director. He will be helping us clarifying some points on our presentation today.
Hello everybody, welcome to our new webinar. Today we will be covering, or Jose Luis will be covering, really the expression engine, Blazedpath expression engine, and I will be commenting along, but this is a language that Blazedpath platform has to customize expressions really, and have most of the code that you will need in your application, your logic, your behaviors, in all layers within the platform, and minimizing external coding. So yeah, today we'll cover some cases and considerations, and yeah, let's do it.
Thank you, Gustavo. So as you guys remember, we've been covering a lot of features of the Blazedpath suite in the past couple of seminars. We've seen the blocky feature to program. We've seen how to build screens. We've seen how to build logic, how to deploy into the cloud, and how to save everything from the one platform. So today we are going to go over a little bit more in detail on how to use the expression editor, which is a part of all the blocky, and it's everywhere really. So it's an expression like you might see in most other programming languages, but it has a couple of differences which we're going to try to cover today. So before we go over to our contents for today, let's just a quick reminder. We are going to, Blazedpath is giving away 5,000 cloud credits for everyone who has registered for today's seminar. And if you open the Blazedpath account within the next 24 hours, you are going to get the credits. So the registration is going to be open for, I think, another hour. So if you haven't already, go over to the link, which should be in the description, and register for the webinar. So let's jump over directly to the table of contents, explain what we're going to see. First, a quick explanation of what is an expression in Blazedpath and what's a bit of a difference with an expression in another programming languages. And then we are going to start going directly into examples with the evaluations that we have for the expressions. We are going to show you how to build objects directly into an expression. We are going to go over a couple of differences between using weakly typed or strongly typed objects, which you can do both in this in the Blazedpath suite, which is very powerful if you rather work with one approach instead of another. You can do both here. And we are going to go over a couple of examples of the functions you can call in the expressions. All of the different options you have from the documentation and from the extensions you can import from the npm.js library, and which I think we covered that in other webinars. And then we are going to touch over a little bit of visibility of functions between different systems, because that's where it gets a little bit maybe complex. It's not just everything everywhere, so there's a little bit of a nuance there. And then we are going to show a couple of basic operators. Then we're going to talk a very important subject, which is context in expressions. And then we are going to show you a couple of examples of the Blazedpath suite core libraries, which are pretty comprehensive. So just so you know how many are there, where you can find them, a couple of examples so you can see how they use and how to read the information that executes. So as for what is an expression in Blazedpath, let me go over to the other. There you go. So we are going to be working in the Blazedpath suite today. Completely of the Blazedpath suite, we are not going to go anywhere else. But all the expressions we are going to talk about, they work. This is the architecture diagram, and the expressions works everywhere. So they work in front ends for mobile application. They work for front ends in the desktop, in any microservice, in any BPM engines, or in any other system you have in Blazedpath. So anything that is inside your solution, they work exactly the same. So you learn it once and you use it everywhere. So that's
yeah. So I wanted to complement that. This is a key point on the expression engine. It's the fact that it is good for the front ends, both web and mobile, for the back end in Blazedpath microservices, for databases, for the process engine, and any other place or any other functionalities that will be adding to the platform will use the same expression language. You'll find that it's very similar to JavaScript, but it differs from it in the fact that you can declare strongly typed variables optionally. So in that sense, you could say it's similar to TypeScript. But the idea is that with this single expression language, you are ready to build at every layer of your solution. And this is makes it much quicker with today's landscape of technologies that are not the same in all layers. Well, with Blazedpath, we have found a common ground for them all. So you can work in all places as a developer, front-end, back-end, database, and elsewhere, learning this very familiar expression language.
Thank you, Gustavo. So as for this expression language, we barely touched it on our previous webinars when we were discussing the blocky programming style we have that the Blazedpath suite has. So we are going to be working in this particular microservice today, in the MS expressions. It's just the microservice we created in order to execute and showcase the different examples. And so whenever I click on the run button here, I'm going to check on the console log, because most of the expressions I'm going to be using today are just a random calculation to showcase how the expression works. So I'm going to output that evaluation for the expression onto the console log so we can see together the result. And since this is a very small text, I'm just going to use the zoom so we can see it better. Just going to clean the log and I'm going to jump over directly. So everything I execute is going to be on the onStart event, so that whenever I click on run, the microservice starts and executes everything that's in here on the onStart event. So that's I think we've covered that on the previous webinars, just so we can recap what we are doing today. So basically our expressions work in tandem with the blockies. So whenever you use a blocky, let's say the console log or the if blocky or the return blocky or the set blocky, pretty much any blocky is going to grab an expression and it's going to evaluate the expression and it's going to do something with it. In the case of the if, it's going to decide if the result is Boolean. It will go one way or the other, like in the if or the else if or the else. If the return block, it's going to grab the value, it's going to throw it back to whoever called the function. On the set, it's going to grab the result of the evaluated value of the expression, and it's going to save it onto the variable that we have on the left side of the set. So basically, you will see that the expressions are on the pretty much usually on the right side, and the blocky themselves serve as a kind of the statements in most programming languages. So what we call expressions here are just the expression, the group of variables, functions, operators that then are evaluated in order to create a value. Whether then I use the value or not, that's irrelevant for today. We're just going to be showcasing what the resulting value of the expression is, and a couple of nuances of how to use it. So let's start over with the most basic examples. The evaluation of just a value, it's going to be the value itself. So if I click on the console log and I give the value 1, 2, 3, and I click on run, and I go to the console, there was one extra blocky that I added. So let's go again, click on run, go to the console. I think you are muted, Gustavo. Maybe unmute yourself.
Yes, I'm back. I'm back with the mic open. So the idea of the blocks is that you don't have to worry so much about the structure and syntax of a block. It's pre-built. You only need to worry about the syntax within the block, which are the expressions. So we'll see that. It's a way of making more accessible the creation of logic to Blazedpath users, developers.
There we go, and finally we get the results of the expression we just used. So let's go back to the Explorer and start reviewing the other examples, since it takes a bit of time whenever I execute a big solution, and when I'm doing many things on my computer. I'm going to be trying to do more examples at once, so we don't get to go through the loading screen so much. So our next example is just how to create an object directly inline in an expression. So let's go over to the expression editor, and I don't think I've explained the expression editor too much on the first attempt. So whenever you click on the 3 dots on a blocky, you will get the pop-up for the expression editor, which you can see 3 main places in the expression editor. We have just the title, then we have this yellowish like part
area
on top,
yeah.
And then we have like a white section where you can just actually start typing. So basically the yellow section is in order to, whenever you are calling a function, you're going to see the metadata of that function, just so you know what the function expects. So let's go over with a quick example. Let's just use, I don't know, the sum. So if you click on sum and you open the parentheses, you see on the yellow section that this is this function is from the Blaze iterable section from the library. It is going to be returning a decimal number, and it's going to take as an argument. The first argument is going to be, well, in this case, it's a list of type, of any type really, and then have an optional in gray. It's in gray because it's an optional parameter. Then you have a selector, because if you do a sum, you may want to be using a selector for the different objects that you have in the array. So just let's forget about this function for now, and let's go over to how to create the object. So these objects here works pretty much very much like in JavaScript. So to create an object, you would just use the curly braces. So this would create an empty object, and if you start adding, properties like string property, semicolon, a value for the string property with double quotes, hello, this is a property value. Then you would go comma and you would start using another property, let's say a number, integer property, semicolon, just a number 1, 2, 3, and then I'm going to just use an array or a list, so you know how it goes. So this would go array property semicolon, and then I use brackets, and in here I can just type anything you want. If this is an array of numbers, you would do numbers, and if this is an array of other objects, you would just again start opening and closing curly brackets and building your object there. The way you might want to do this is because maybe the first time you're trying something, or maybe you're trying to map something manually for some reason, and so this is a very useful way to start writing objects inline, so you don't have to think about creating a type that represents something for your function or whatever you want to try. So this is how to create an empty function, an expression that has a defined value of an object. So whenever this function is executed, it's going to evaluate this expression, and it's going to result in the value itself of the object. So then we're going to start going to different kinds of behaviors that you use in tandem with Blocky. So this is basically evaluating and throw it onto the console log. Like we saw, if we use an execute, it's going to do nothing with the resulting value, but it is going to execute the function itself. Maybe you're doing a transaction, maybe you're throwing something onto a store procedure, whatever you want to do that you don't care for the resulting value, you just use an execute. And if you do care, you would use a set Blocky and save the resulting value on the variable we have on the right. So this is a good segue on where do you save the value that you have. So as we mentioned previously, we have both the capacities to use strings and weakly types of objects. And in this case, how that looks is, let me create two variables here. So a weakly typed object would be of type any, because it can be anything. So we have a defined object that you can do anything with. So I'm going to call this variable weakly defined object, and down there I'm going to use a string object which is defined, and it's going to be necessarily a string. It's going to be my strongly typed object. So now that I have this, what can I do with it? So on the weakly defined object, I can save anything. I can open the expression editor and just type 1, 2, 3, and the weakly defined object is going to be a number. If I instead type an object and I do the property semicolon hello world, this is going to be saving an object with a hello world property, with hello world value on the property.
So let me ask you a question. Can you define it? Do you need to define the brackets even though it's not an array? In this case, just a single property.
Excuse me, come again?
Yeah, so that bracket, do you need a bracket?
No, the brackets are only for when you want to use an array. This is just an object. An object Good. Which has a value, a field, named property. This should be called field with a string. So this is a property with a field of a string, and if you want to use the brackets, those are exclusively for strings, much like in JavaScript or any other programming language based on JavaScript or JSON. So as for the strongly typed object, you can only save strings in here. So I'm going to use hello webinar, we are talking expressions. So that's the only thing I can save there. You can try to save something else, but we have 2 checks in order to that not to happen. So whenever you click on run, if the right side or the expression does not result in a typed string, it's going to throw an error on on developer time, on compile time. So if I click on run, right now it's going to work, but if I instead type, let's say, a 1, 2, 3, and I click on run, it's going to throw me an error. Let's go to the console so we can see the error. So it says expected type mismatch expression 1, 2, 3. It's expecting a string and it received an integer. So we do have controls in order to that not to happen. But of course, if you use any as the object, just the compiler understand that you know what you're doing, and you maybe have something dynamic that you may or may not have different properties. So it's not going to care, and it's up to the user or the API to check whether the information you're looking for is in the object or on the result you're looking for. So
you can use both strong types and weak types of variables.
So that's on the object types. Again, if this is correctly a string, this is another nuance that you may want to try for the webinar. And then you want to use, there you go. And then you want to use an expression. Let's just use an execute, and then use a strongly typed object, and then you use a dot, and then you're trying to use a property here. Let's say you think this object was supposed to be dynamic or weak, then there's supposed to be a property in there. So fictitious property. So whenever you try to execute this, it's going to give you another error in compile time that says, hey, that's a string. There's not supposed to be any property in there. Check what you're doing. So make sure that whenever you are working with a strong typed object, that you check that you always work within the boundaries of those objects. You can, however, use a strongly typed object with a big structure, not just the primitive ones like string, integers, or whatever. You can assign a property with a dynamic object inside the strong typed object, so you can have both worlds as long as you know what you're doing and you are expecting a big object inside another object. So our segue to that is, okay, that's all good and dandy. These are how to define objects. What can I actually do here? So we talked about how these are usually a group of operators, functions, variable that ends up in evaluation of something. So let's see a couple of examples of operators that we have available. So I'm just going to open the library operators in here. So you can see the different operators you have. These are, again, based on JavaScript. So they are pretty much what you would expect. You have the sum, you have the difference in here, just a normal, the usual signs. You have the division, you have the remainder. So this would result in 1 because it's 33 times 3 gives you 99, and the remainder is 1, so it would result in 1. Then as for the logic operators, you have like the booleans. You have the true, and the double ampersand refers to the AND operator. So true and false is going to yield a false. If you have a true or a false, is going to yield a true. And as for the nots, you would just use the exclamation sign, and this would be yielding a false because it's not true, and that would be yielding a false. So those are basic operators. They are pretty much based on anything based on JavaScript. You might you might see them everywhere. We also have actually the comparison operators. So to actually yield from an expression, you can yield a Boolean. So let's say 1 is double equals to 1, so this will always execute an equals. Then if we use, where's the console log? Yeah. So then you have the other comparisons. So 1 may be greater than 0. You can also use the greater or equals. So 1 is always greater or equals to 0. These work this way. They are not like equals and greater. So it's greater on the left and equals to the right. And the other one is the not equal. So that would be exactly as you would expect from JavaScript. So 1 is not equal to 0. And this will be yielding a true. So that is as far as operators go. They are pretty common. We're not trying to reinvent anything. It's just the normal operators you will find anywhere else. So you will maybe already know what to expect. So now on to we're going to start talking about functions that we can use on the expressions, and we are going to talk about a little bit of what's available on the expression editor, what's not, and maybe you want to call functions of your own. So I'm going to open an expression, and I'm going to start typing a function that we've seen already in here. I think it was the sum. So sum, I open the parenthesis, and it's giving me the expression editor header, the metadata of the header. So if you want to learn more about a certain function you're typing, so let's say you already know how the sum works, but you want to use something more advanced of this function, for all functions in the Blazedpath default library, you can just click on the learn more in the expression editor itself, and it's going to open the documentation with the function you are trying to find, and you can see everything in there for your functions. So just log in and close the other window. So it opens directly the functions sum, and we have on the documentation examples of maybe you have this particular example, you're passing over to a list with a couple of objects. The objects have the number you want to sum in a particular field. So this function helps you solve the problem in one line to filter a certain list by certain criteria and do something with the, well, in this case it's a sum, and do something with those numbers. So whenever you see a function you want to go more in depth, in here, if it says learn more, it's a function that's native to the Blazedpath default library, and they are fully documented, and you can, with one click, you can just go to the documentation and see any details you might want to see. So let's say this library that we are going to see a couple of examples later. If you can come here to Essentials, you can see you have an iterable library, which refers to management of lists. We have examples to show later on. We have mathematics with most of the normal mathematical functions, trigonometry, sums, differences, the whole thing. We have to manage strings. We have for cryptography to manage datetimes. For MongoDB, we'll have a lot of functions in here. So let's say that you want to use more for some reason. You may want to be calling upon a certain library that you don't want to write a library from scratch. So how do you expand the scope of the function you have on the expression editor? Well, we have two ways to do that. So the first way is to just go over to the package, the packages for the store of Blazedpath. So in here you have a bunch of packages that you can import on your solution. So in this case, as you can see in the up-to-date section here, we already added a package that adds SMTP libraries to send emails in this function. So the help for these packages are on the name itself. It's going to open up a window, and you can see the different functions that this library adds. So you have these APIs, SMTP send. So this package, if you go back to the console and you go back to the event and you open the console log and you open the expression and you start typing SMTP, you can see both APIs of this package I just added. And if you open the parentheses, you can see the header of the function. So that's one way to expand the availability of the expressions editor. The other way to expand it we covered is in another webinar, but you can import anything from the npm.js library. Here we added a library called Factorial just to show you how it works. So you create the extension, which are basically 2 lines of code. Let me just reopen it so you can see it. So just create the function, and on the code itself, you just use the 2 lines of code to instantiate the library and return the value of the function you are calling. And you can now have this factorial npm.js function in all the Blazedpath suite itself. So I'll go back to my solution. Whenever you do a change in an extension, it's going to reload the application, so you have this function available everywhere. Since now it's compiling it and it's getting it available everywhere, it's just doing a quick reload, so it's available everywhere and on the cache.
This is one of the ways in which Blazedpath is truly extensible. So though the expression engine has a language that's familiar and in a way proprietary, it's really what it's producing is basically JavaScript underneath. And the way that we have of importing any npm library and have it immediately available as part of the expression engine is an evidence of the extensibility of it.
So
and
that
powerful it can become. Yep.
Thank you, Gustavo. So that function that we just talked about, so the factorial npm.js, open the parentheses and you see the function. It's just taking the factorial of a number, just a way to show you how to expand the scope that you have on this expression. It's very powerful. Usually whatever you might want to do, it's already done somewhere else. In this case, just adding the library itself, it's just 4 clicks away. So it's very easy to just import anything you want. So there's a nuance on what's the visibility of the functions you have. Not the ones you have by default, like the ones we've been talking about, but let me just go over back to our architecture diagram so we can quickly discuss what I'm talking about. So right now I'm working on this microsystem. So this microservice is executing a bunch of functions inside itself, so there is not really any problem to execute anything inside of it. So you have like full visibility of everything that is inside of the microservice itself. But the problem of visibility comes whenever you want to try to call something that's somewhere else. So in this example, the expression editor, the microservice expressions here, it's connected with a reference to this other microservice, which is just managing a database. So we have a couple of functions that administer the database, such as the creates and the read and the gets and the updates and the deletes. So all those functions are exposed as a REST APIs. So whenever I call something from here that I'm calling it from the original microservice, I'm going to have visibility because I'm connected to the by the arrow. But if I'm trying to call something from the web application that is existing in this microservice, since there is no really an arrow connecting it, you're not going to see it in the expression editor. So the expression editor is filtering only by the functions that the microservice or the system you're on has directly connected. So in this case, the web application, the expressions on the web application will see everything in the web application itself and everything exposed in the microservice expression, but it's not going to see anything from here. So if I go to the web application and I try to call it something from here, from MSDB, I'm not going to see anything, and it's going to give me an error whenever I try to execute the solution. So just so you see what I'm talking about, this is the web application, this is the onload event, and the way you want to call the functions that are on the, just use a console log, just reuse this console log. The way to call a function that's on another system, you would start typing like ms expressions dot, and you would get the resulting numbers. Actually, I don't think you will be able to see it so good on this event because I don't have anything exposed on expressions. So first I want to show it on the expressions here on the onStart. So let's use a console log, and then I am going to be able to msdb. So as you can see, you type the name of the system connected to the expressions, and this is the name of the system. Then you go dot, and you would get all the functions that are exposed on that system. So create career records. These are just functions. We don't care right now what they do. Just know that they are there, they are exposed. So if I try to do exactly the same on the web application, which goes through the expression back to the microservice that manages the database, I am not going to be able to see anything in there. So go to the onload event of the web application, and on the console log, I'm going to start typing msdb dot, and I don't see anything. So if you don't see anything, it means it's not connecting, and the expression editor will tell you that create course does not exist. So this is not going to work. So finally, the final nuance we want to see is the context on functions. So the context on functions, it's going to be a little bit tricky at first, and it relies on notation quite a bit. So let me go over a quick example of what I'm talking about. So for this example, I'm going to create an action that it's going to require the use of proper context management, and you will see the two different results whenever I take care of the context and whether I don't. So I'm going to create, let me delete the other variables so we don't pollute our example. So I'm going to first create a filter value, because I'm going to create, I'm going to be evaluating the behavior of a list management, and for that I'm going to create a list of any. So this list is going to be called object list, and the first thing I want to do is to give my two variables a value. So just use two set block keys. The first one is going to be for the filter value, and the second is going to be on the object list. So the filter value, I'm going to be giving the number 3, just because, and on the object list I have a little array prepared on a notepad that we can use here. So basically I'm defining here a value of an array. This starts with the brackets, and inside the brackets you can see with JSON notation that we have 7 objects in the array. Each object has a property called value, and they all have different values. So we are going to start managing this list and taking care of the context. So what I'm going to do is, since it takes a bit of time while I'm streaming, I'm going to be doing 3 different context approach. So the first one, I'm going to be using find first. This is a function that is going to retrieve the first object that complies with a certain condition. The condition I'm going to be using is just I'm going to filter the value we saw on the array. That's a certain number. In this example, it's going to be I don't know, 3. So I'm going to filter the object list, and the reason I'm using a circumflex before the object is part of this example. So I'm just going to delete it for now so you can see the difference. So the object list, the parameter on the left, it's going to be the name of the list I want to manage, and the parameter on the right, it's the condition I want to give my function in order to filter out the first entry that complies with this condition. So my condition here is going to be that value must be equal to 4 and close parenthesis. So this is going to be yielding the object with the value 4. My second test is going to be the same function, find first, with the object list. And my second condition is going to be that value must be equal, instead of 3, to filter value. And my third test is going to be that my find first function of the object list has the property value equals to the filter value, but using the circumflex. And if I didn't forget to delete any blocky on any other that I never finished, it's going to go over quickly. So let's go back over to the console log so you can see the 3 different results. So let's go over the 3 console commands I just did. I have a list of 7 items. The first one is I'm just passing over a hard-coded value. The second one, I'm trying to use the variable without the circumflex. And on the last one, I'm using the same variable name, but with the circumflex. And the reason this is very important is because this is just a call to a function, but your expression might be very complex. So your expression might be a function, inside a sum, inside a division, inside a function, and maybe that solves whatever you want to do. So you may have a lot of context changes in an expression. So to manage context changes and avoiding problems with maybe the name of your variable, you forgot to change the name and it's exactly the same name as a property inside an object, so that will create a problem. So these are my resulting values for the console logs. So as you can see, first I have the object that complied. So it says value 4 because I hard-coded the value 4. The second one that doesn't have the circumflex gave us a null, so it didn't find anything that complies with that condition. And on the third one, we did get the object that had the value 3. And the value 3 comes from the set of the variable. So basically in here, the circumflex serves to the expression editor to let it know that that name filter value that I have here comes from outside the expression editor, and it's most likely a variable inside the function itself. So this is very important to whenever you're using variables inside an expression editor. You might get no problems, because if there is no context change, it's going to interpret the variable as itself if you don't use the circumflex. But just so you don't have any problems anywhere, anytime, just even if you don't need to, just always use the circumflex to let the expression editor know that whatever you're writing is a variable, and you will never have problems with context again. So after that, we wanted to go over a couple of examples of how to call the different libraries we have by default on Blazedpath. So I'm just going to call my library example. This is a function I created on this microservice that is basically a showcase of all, not all, but a couple of different functions here and there from different libraries. So in the first two, we have two functions. One is calling an arcotangent of a value. Then we are calling a factorial number of the extension we added. So these are two mathematical functions. Then we have two string management functions. One that is yielding a Boolean that just lets you know if this string is contained in this one. Then you have a search and replace function here. So I'm just going to click on run while I finish explaining what each one does. It finishes. So then we have two examples of list management. One is the one we just saw, that like find the first object, and then we have the find all example, which instead of just returning the first one, it returns all of the possible entries. So then we have a couple of of the core library. Just if you are using a certain strongly typed objects, you can just use the convert to string, convert to number, convert to datetime, have all the converts you might want to use whenever you're using primitive variable names. And then have a couple of examples of encryption and decryption using just a random key. The first one encrypts the hello world phrase with this key using this algorithm. And on the second one, I'm decrypting the result of the first one of the hello world using the same key, so it's going to yield finally the hello world. So if I go to the console, you will see all the outputs of all the functions. So this one are from the expressions. Then I have the arcotangent, the factorial. Then we have the contains. Then we have the search and replace, and well, you get the picture. It's all the outputs of all the functions. So those functions come from the core library here in Blazedpath Essential, the Appendix B. All of these functions that we are using are fully documented here. So let's say you want to see the nuances of on the lists. So the find all we just used, it's documented here with examples and how to use the conditions and anything you might want to do. So I think that concludes the presentation. Let's switch over to Q&A and check if there is anything questioned. I'm sorry for not reading the chat while I was speaking.
Yeah, so we see that there are two questions. First from Sanjeev.
Yes, hi, what are the benefits of using a proprietary programming language? I think that's for you, Gustavo.
Yeah, well, so the benefits our users see the most is first its similarity to JavaScript. Second, the fact that it is the same expression engine or editor or language for all layers of your solution, whether you're working on the front end, back end, like we explained at the beginning, even for databases. We'll see in an upcoming webinar how we interact with non-relational databases and how in that sense, or even for relational databases, how the expression engine, you can write queries, you can do statements, you can do interactions with the database and execute commands with expression engine. So you can work at all levels with the same language. So you learn it once, it's very similar to JavaScript. You can use it both as strongly typed or weakly typed, as explained. You can have it throw exceptions in at compilation time or at runtime. And we think since Blazedpath is for professional developers, they will most likely be familiar with JavaScript already, so it should have a rather short learning curve. You should be able to write expressions rather quickly. There are a few nuances. So, for example, the brevity, the syntax, the fact that you can write microservice.function within an expression. It's such a short syntax to call a function that exists on a REST service external to the one you're working on. Also, the usage of the circumflex to refer to variables referred at the function level and not within any change of context that you've done. So all those things are like helping you write less code. The fact that it still looks like coding, but it's really an expression, and most of the logic, flow control, syntax is governed by the block itself. So the structure and the syntax of the logic that you are entering is governed by the block. We're just limiting the expression, the things you need to write to the arguments of these blocks. So yeah, we see that overall it will give you a lot of flexibility and expressive power to not have to write custom code outside of Blazedpath, to do most of your project within Blazedpath without having to redeclare variables, redeclare connections. So it makes Blazedpath in that sense really powerful. Well, the fact that it's extensible also is another proof. You can immediately wrap any JavaScript function and use it inside your expression editor like that. It's another benefit for using it, another argument in favor of it. So yeah, I hope that covers it.
Now for Jim Adams, one question: does your platform distinguish between expressions and statements? So the statement themselves are pretty much implicit in the blocks themselves. So you may have a statement with just an assignment, so that would be a set block instead of just using the expression editor. The answer is yes, we distinguish them, but just that usually the expression is inside of the blockies, and the statement themselves would be somewhere in the blockies. So yeah, pretty much whenever you're looking for a statement, it's probably more on the blockies instead of the expression. There's like no assignments in the expressions themselves, so it's pretty much differentiated. Yeah. So I think that's all of the questions. It was a slow chat. So for the next webinars, we are thinking of going into more detail on the expressions to manage both databases, the relationals and the non-relationals. We're going to go over a couple of examples for MongoDB and a couple for SQL-based databases, which we are not making any distinctions. Both works for the same. So, and upcoming webinars, we have a special one for show you how to debug using Blazedpath. And we have a couple of examples on how to program using the keyboard and how to copy and paste using the keyboard, move blockies around, create new blockies, everything without using the mouth, which for some people is better. And then we have and examples of how to, instead of just deploying to the Blazedpath cloud, we can just deploy the pod directly to the Google Cloud, and then you can create the exposure, the deploy itself on the Blazedpath cloud. So that's pretty much everything for today. Do you want to have any other comments, Gustavo, before we close?
I just wanted to thank everybody for joining, and yeah, we'll be continuing doing these webinars, so they will be here in our channel as a reference for new Blazedpath users, so they can maybe use this as a resource to become productive as quickly as they can. We'll continue with this series, and thanks again for joining. We'll see you the next time.
Thank you. Just remember, if you stayed until now, please remember to subscribe and like the video, so we have it helps us out a bit more. And don't forget to register on the web page if you want those 5,000 extra credits. Thank you so much, and see you on the next webinar.